With this understanding of how the unit circle is related to trigonometry, we're ready to talk about the graphs of the sine and cosine functions. And the way that we're going to think about this is we're going to focus on the roots and extremes of the sine and cosine. So by roots, I mean where does the function equal 0? And by the extremes, I'm interested in where's the function its highest and lowest point. Because I'm on the unit circle with a radius of 1, the extreme values are going to be plus and minus 1. So we're going to focus on our circle, what gives me a y value or an x value that are equal to 0, plus or minus 1. All right, so let's start with the sine function. Y equals the sine of x. And this is an interesting transition. We've just been talking about the measure of a circle. We've usually used a Greek letter theta to measure our angle. And now all of a sudden I'm talking about x as an independent variable, not a coordinate. So here I'm thinking about x as the input to a function, and the function is the sine. So x is going to measure how far I travel around the unit circle. So x is the distance around the circle, and y, the output of the sine function, gives me the y coordinate of the point on the circle. So y is the vertical coordinate of my point when I go on the unit circle. All right, so let's think about the unit circle. I want to know where does the y value, where's the vertical coordinate equal to 0, and where's the vertical coordinate equal to plus and minus 1. So as I go around the circle, I've got a y coordinate equals 0. As I travel around, when I reach the top of the circle, I have a vertical coordinate of y equals 1. As I continue to go around the circle, I come back to a y coordinate of 0, and I end up again at y now is equal to minus 1 at the bottom of the circle. And as I continue to go around the circle, I start repeating. So I go 0, plus 1, 0, minus 1, 0, plus 1, 0, minus 1. And I just need to know what angles do these correspond to. So as I travel in the counterclockwise direction, I first reach my maximum at an angle of pi over 2. So here I'm at pi over 2. And if I travel another 90 degrees, I've now traveled 2 pi over 2, or I'm at the angle pi. And I keep adding half of a pi, so I've got 1/2 pi, 2/2 pi, the bottom I'm at 3/2 pi, I'm at 4/2 pi, that's 2 pi, so this is actually 0 and 2 pi. And as I keep going around, 4 pi, 5 pi over 2, so I'm at 5 pi over 2. This list keeps going. Each of these I repeat infinitely many times. So 3 pi over 2, let's see, 7 pi over 2, 4 pi, and that's all going in the counterclockwise positive direction. But I could have gone in the negative direction, so I could have also gone in the negative direction, which means that if I ended at negative pi over 2, I end up at the bottom. If I end up at negative pi, I'm at the left. Negative 3 pi over 2, I'm at the top. Negative 2 pi, I'm at the right. I can go around infinitely many different ways in the clockwise direction as well. Okay, what does that do to my function? So as I graph my sine function, let's put my axes on. I have a highest value of 1, a lowest value of minus 1. So these are the vertical coordinates of the points. And this x is the angle I travel around the circle. And notice that we were making measurements at pi over 2. So we have pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, and I just count. I'll write down every other one. And that's the positive direction, and I also go the negative direction. So I'll write down plus and minus multiples of pi. And let's mark in our half angles as well. So as I travel around the circle, when I was at 0, my vertical coordinate was 0. At pi over 2, I was at a maximum, then 0, then minus 1, and I just repeat this pattern over and over again. And I get a nice, I get a nice sinusoidal curve. That's the name of this shape. And this repeats forever. It's a periodic function. And it goes in the opposite direction as well. And so this is what the sine function looks like. The important things you need to remember: I've got a high. All of these peaks are at a height of 1. All of the troughs, the lows, are at a height of -1. And the sine function starts at 0 and repeats every 2 pi. So there's this basic shape that repeats over and over again. Okay, well, let's now talk about the cosine function. Again, x is measuring the distance I travel around my circle, and now this is going to sound a little confusing. The y value of my variable came from the cosine, and the cosine gives me an x coordinate. So I'm going to call it horizontal instead of x. So I've got the horizontal coordinate of my point. I'll be using the same x coordinates, multiples of pi halves, because it's the same basic points that we're interested in. So let me write down the multiples of pi, and we'll mark all of the half multiples as well. The cosine starts at a height of 1 because when I start at angle 0, my x-coordinate, my horizontal coordinate, is positive 1. And so I start at 1. As I go around the circle and I reach the first corner, I'm now at pi over 2. The x-coordinate has fallen to 0. And as I now continue, when I get to the left side of the circle, my horizontal coordinate is now -1. And as I go around, I go through 0, +1, 0, -1. This is actually the same shape as the sine curve. It's just been shifted. So the curve that we've just created looks the same. It's just been shifted to the left. And so it goes backwards as well. With highs and lows, every multiple of pi, and we're crossing the axis on all the odd multiples of a half pi. Again, this is a periodic function. It repeats every 2 pi. And the basic block that we're looking at here, remember the cosine starts at 1 because I'm at the right side of the unit circle. The second major concept that we need to be able to do is start with a unit circle and some information to find the value of sine or cosine. So if I know one of the values, either the sine or the cosine, I need to sometimes find the other value. And the way that I do that is I take advantage of knowing which quadrant I'm in. Here's an example. Suppose that I have an angle that ends in quadrant 4, where the cosine of an angle equals 1/3. So quadrant 4, if I think about quadrants, I start going in the counterclockwise direction. Quadrant 4 is the 4th quadrant I arrive in. So I'm interested in the quadrant on the bottom right. And as I look at the cosine of my angle equals 1/3. So cosine of the angle equals 1/3. My task is to recognize that the cosine is the horizontal coordinate. And so I get an x value equals 1/3 on the circle. So let's go to the circle. A circle that we're looking at is a unit circle, so this is position 1. And so 1/3 is going to be a third. That looks about right. So this is 1/3. This would be 2/3. I'm interested in a point on the unit circle with this x coordinate. So I'm going to think about this line. This is the line x equals 1/3. And you'll notice it crosses the circle in 2 locations. I've got a point in quadrant 1 and a point in quadrant 4. And of course, we're interested in the point in quadrant 4, not the one in quadrant 1. So I know the x coordinate, but I don't know the y coordinate. I'm interested in this y value. How will I find it? Well, I find it from the Pythagorean identity. X squared plus y squared equals 1. The cosine is the value of x, so 1/3 squared plus the sine squared, that's y squared, equals 1. I get that y squared plus 1/9 is 1, or y squared must equal 8/9. When I finish solving for y, I find y is plus or minus, it's quadratic, square root of 8 over the square root of 9, and the square root of 9 is 3. We often recognize that 8 is 4 times 2. 4 is a perfect square, and its square root is 2. So this is usually written as plus or minus 2 square root 2 over 3. I have to choose if it's positive or negative, and because I'm in quadrant 4, we'll choose the negative sign. What that means is my coordinate for my point, x we knew was 1/3. Quadrant 4, my y coordinate is negative 2 root 2 over 3. The first coordinate is the cosine of my angle, and the second coordinate is the sine of my angle. Consequently, we can say that the sine of my angle is negative 2 square root 2 over 3. So when I am given a question where I need to find either the sine or the cosine when I know the other value, I also need to know the quadrant. I can solve the Pythagorean identity to find my other coordinate. This is the level of understanding the unit circle that's often not understood when students just memorize certain values on the unit circle rather than learning how to solve for this value.